This is a quick video about equals and hashcode contract. The contract basically says equal objects must have equal hashcodes. That means whenever you are providing a logical equals implementation in your class, you should also provide a hashcode implementation that is meaningful, without which your class will act strange and cause bugs when it is used in hash-based collections like hash maps, hash tables, or hash sets. So given that, it's very important that you provide a meaningful hashcode API as well when you provide an equal method implementation. So this was popularized by Josh Block in his famous Effective Java book, and he has discussed it very clearly in his book. So if you haven't read that book so far, and if you're a Java developer, I recommend that book. It's very useful and it's very easy to read. So now, anyway, let us see what happens if you do not provide the hashcode implementation. So for that, I'm going to go to my IDE and try to run a couple of examples and see what happens. So here, let's create a new test class called contract test. So in this class, what I'm going to do is I'm going to create a dummy class called class employee key, and I'm going to use this as a key on a hash map. That's why I'm calling it so. So let's assume that the employee key has two fields like string employee ID and string date of birth. So let's create a constructor for this with two string arguments. So this constructor takes two arguments and assigns to its variable the ID and the date of birth equals, the field date of birth equals the date of birth. So now this is the key I'm going to use, which is the employee key class, and I'm going to provide an equals method to compare two employee key objects. So basically the two employee key objects are logically equal when they have the same employee ID and same date of birth. So now I'm going to implement an equals method. I'm going to just use ID as default implementation, and it says next. I'm going to create, note that I'm not creating hashcode implementation. So here, so IDEA has created the equals implementation for me, and this checks if date of birth equals the given object's date of birth and employee ID equals the other employee object's employee ID. We are saying those are both the employee key objects are equal. So given that, let's now go and create some test scenario. So let's assume we have an application that loads a bunch of employee data from the database and tries to build some kind of a cache using hashmap. So now I'm going to write a method here called static map of the key is going to be employee key, and the value I'm going to put a string value, and that's a method called load employee cache. So let's assume some DB operations are done and we are populating a hash map of to represent the cache. So for now, I'm going to create a mock implementation, which is basically hard-coded employee key and values. So first step is to create employee key. Employee key 1 equals new employee key of employee ID, which let's say 100, and date of birth is 10/10/1984. So let's create a few more keys. Employee key 2, employee key 3, and let's add 101 and 102 with some different dates. Alright, so we have 3 employee key objects created. Now let's put some data on a hash map, and return it to the column. So map employee key comma string cache equals new hash map, and the map I'm going to put some values, cache.put ek1, and let's say we are putting the names. So this is Bob, and ek2 I'm putting Steve, and ek3 I'm putting let's say Robert. So once this is built, I'm returning this to the column, return cache. So let's assume this is our load employee cache implementation. This is hard coded for now. Let's assume this was done through some database or something. Now I'm going to use that the cache that is loaded. So let's map of employee key comma string cache equals load employee cache. So now I loaded the employee cache, and I have 3 employees in that map, which is Bob, Steve, and Robert, with these keys assigned to them. So now, given my cache, I want to look up. So I'm going to create a key, employee key lookup key equals new employee key. Suppose I'm creating a key same as that of 101, which is actually assigned to Steve. So let's try to create the same key. So a new employee key of these 2 parameters. So I created the same key. Now my next step is to say string employee name equals cache dot get lookup key. So my expected result is that since I used the same employee ID of 101 and the date of birth 11/10/1974, and which is assigned to Steve here, when I should get the employee name back as Steve. So now let's try to run this example and see what the example prints. See that when we run the example, we get null instead of Steve, which we expected to get. So that means since you missed implementing hash code, the system is not able to look that up in the map, even though there is a very similar key out there in the map. So if the programmer or the developer was not aware of the contract or was overlooking the fact that hash code was required, he will be totally puzzled why my hash map is not returning the expected result. So that's the case. That this is what happens if you do not implement hash code. So now let's try to implement a hash code on the employee key object and see what happens. So I'm going to rely on my IDE to generate a hash code implementation for me. So I'm going to use these 2 fields which are important in the class to generate the hash code. So here we go. So this is the implementation of hash code that IDEA provided me, which I'm pretty much satisfied with. And with that, I'm going to rerun my example program and see what the output is. Now I get the expected result Steve back because I implemented hash code. So now I think you would understand what is the significance of following the equals and hashcode contract. Also, I would like to demonstrate one more thing. Suppose again I'm going to delete this hashcode implementation down here, and suppose let's try to add all these things into a set and see what happens. So the set by definition is going to contain only unique items. So let's create a set. So I'm going to take delete all this other example here, which was demonstrating what happens with the hash map. Okay, so I'm going to create a few items: employee key ek1, ek2, ek3, ek4, and ek5. So now let's assume we created, these are all duplicate data. See, this is same as this, and these two are same. And suppose let's make this unique, like 103 and some other date, and this. So now let's try to add this item to a hash set. So set of employee key set equals new hash set. So my expectation is that whenever I add duplicates to the set, so the set will automatically take care of it and give me only the unique elements back in the set. So let's try to do that and see what happens. Set.add ek1, ek2, ek3, ek4, and ek5. I'm adding these to the set, and let's now print the set contents on this screen. So for that, I'm going to provide a toString implementation here so that we can see what happens when we try to add these objects to the set. So now let's run this example and observe the output of the contents of the set. So as you can see, the set has added duplicate elements into the set for employee key. Here, say 102, 102, this date 11/10/1974, 11/10/1974, and see 101, 11/10/1974, and 101, 11/10/1974. So we have easily added duplicate items, though our logical equals method should have prevented. But so that's what you would think. So without a hashcode method, your object will cause bugs when it's added to hash maps or hash sets or hash table, as we just saw. So for that, what you should do is you should always implement hashcode along with the equals. And if you do not know how to implement hashcode, which is a kind of a tricky steps to implement, you should always depend on the IDE to generate one for you. And all the modern IDEs, let it be Eclipse, IDEA, or NetBeans, all these IDEs create very decent hashcode implementation, and you can always trust on them and just follow it. So I'm just going to create an automatic hashcode implementation for me, and I'm going to rerun this example and make sure at this point the duplicate items are eliminated from the set. So I'm rerunning this example, and if you observe the output, you would see now the set only has unique items. So now I guess you might have understood the significance of equals and hashcode contract. So up until next week, please subscribe to my videos if you are interested in the content, and let me know if you have any questions or comments through the YouTube comment. Thank you.